Sometimes I think that the analytical sciences community may overthink throughput. It is important that our technologies are able to scale to meet the needs of researchers. And it is true that, for example, people studying populations at epidemiological scale need the potential to analyze hundreds of thousands of patients and things of that nature, right? Especially for these big exposome studies that we're talking about. But the throughput at which it's done has to be fit for purpose. It doesn't have to be the highest throughput ever, because you may sacrifice data quality when you drive things to the extreme. So I tend to think that's perhaps an area of overfocus. Whereas just ensuring that analyses are fit for purpose and provide the highest quality of data, that's something where I think maybe should be a little more balance there.
That's a great question. I believe that a lot of times the analytical community can get bogged down in like the cost of acquisition of an instrument or a workflow solution. I think reeling that back, it's really important to say, what value does it bring to my operation? It may cost a little bit more up front, but it's going to save you over time. Those calculations have to be made. And I think there are customers who are purely focused on the acquisition cost. And then there's customers who do exactly what I just said, is they look at the total value that's delivered and how does it help my operation be more effective. And I think we're getting there, but it's also comes back to companies like Agilent trying to actually hit the needs of the customer and be able to provide that value and articulate that value, so it's easier for them to kind of internalize, if you will.
I've often felt in the minority of my area, and so it's perhaps self-serving, but the area of proteoform systems biology and medicine, that is what I call now lovingly long-read proteomics. And this is the use of the whole protein that naturally occurs in our biology and our bodies as the unit of measurement. And I think that has been overlooked, but right here at ASMS 2026, we're actually not overlooking it, as far as I can tell, anymore.
Efficiency in the lab, throughput, there are key ones, right? Sample throughput always going to be at the top of the agenda, and it very much depends also on the type of application area. Like, for example, if you're running an operation where you're monetizing your investment, you know that you want to run as many samples as possible, return the answer to the customer so that you can monetize your investment, right? So I think that it's more like, running a very tight operation, so to speak, right? And also the cost associated with that, right? How can I run a very efficient lab with minimal cost, or a way that you can control cost, right? The science is important, 100%, but you have to be able to run your lab efficiently, essentially, right?
Yeah, so there's a number of examples of where AI tools are already being deployed. So one of the areas is around machine learning of data processing algorithms. So this is really where we can teach the model to understand how better to process the data so that there's not any human intervention required. So it learns, what is the best algorithms to apply, and then applies those routinely across a large cohort of samples. One of the other areas is around servicing and diagnostics of instrumentation. So this is again around having access to what are some of the common faults when an instrument is in a fault state. How do you more easily and quickly diagnose what it might be, such that when a service engineer turns up, they'll have the right part and they can fix the instrument as quickly as possible. So those are just a couple of small examples. Then we get into other areas such as large language models, and this is really where we can take an enormous amount of information and distill that down into, for example, being able to develop a method automatically for the user rather than the user having to do that themselves. So that's really where we see significant advantage of some of these AI tools.
In terms of AI in general, one could associate it with productivity gains, right? And I think that that's the area where we're going to see, I would say, a lot more work done on. And for example, what are the mundane tasks that you do on a regular basis that can be automated? Whether, report generation, where you just basically set up the conditions or the rules by which the tool will allow you to, develop the report that you require. That's one area. The other one is what I'll call the loop, right? Where, you don't allow AI to make complete decisions for you, but they become parts of your workflow, if you know what I mean, like your assistant, for instance, right? Like there's always going to be a human decision made at the end of it. But what is good, for example, if you're doing like, data review and you're looking at big integration and you have hundreds of chromatograms that you need to integrate it, where this is going is, please tell me which chromatograms are not accurate or they just not been integrated properly, so I can go back and look at them, inspect and review it, right? So it's always that user intervention, working closely with the tool. That's how I mostly see it from a data processing and workflow standpoint, but also from the point of view of diagnostics, like instrument diagnostics, providing information to the user that will allow the user to have preventative maintenance, for example, right? And knowing when you need to basically reset the system or clean the system to make sure that you continue to generate good data all the time. That's where I see the AI tools working in an environment where it becomes more like an assistant than anything else, right?
Yeah, so I mean, in structural biology, the big breakthrough was the development, as I said, of AlphaFold and RosettaFold to try to predict the structure from a sequence. However, what is not necessarily advertised as much is that we still don't understand how proteins actually do fold. What are the kinetics of folding? The other thing that they're not still very good at is predicting intrinsically disordered regions. So these are regions that, in proteins that don't adopt a specific conformation. So there is necessarily no data to train them. And also, predicting protein-protein interactions on a global scale is still a challenge. So I think, we still need to perform measurements. To train proper AI models, you need balanced data sets. So it's coming out in a lot of fields that the data sets are not necessarily balanced. But then on the positives, it's been great for our lab for developing tools to process our data. So you can now write some programs or to look at the data very, very quickly, and that's been accelerating what we can do.